Today we are talking about creating a global scale game with Google Cloud. Just to give you some heads up of what we're probably going to be talking about today. So we're going to be doing sort of a high-level overview of a demo that we built over the last, actually, year or so, giving you a lot of sort of summaries of the highlights of what we've done and how we've built this global scale multiplayer game. So we're not going to be doing like necessarily a deep dive on a particular technological topic. What we're trying to do here is give you some summaries of some of our favorite tools, techniques, and products that we have at Google Cloud, and some other ones as well, so that you can walk away and be like, hey, this thing over here seems cool. I can put that in my toolbox. This thing over here, maybe it doesn't apply to me, and I can like maybe discard that for a later date. If that doesn't sound like something you're interested in, that's totally fine. Door's over there. It's okay. I won't be mad. It's totally okay. But that's sort of what we're getting into. Cool? Cool. All right, let's do it. Little bit about me. That's my face. Hi, I'm Mark Mandel. I tech lead developer relations at Gaming at Google Cloud. I primarily work on a ton of open source tools. Well, maybe not a ton, a couple of open source tools for backends for multiplayer games, one of which we'll talk about today. My details are up there. I will say as well, if you have questions, we're not going to take questions live on stage today. I can take some after the fact, but also my business cards are right up here as well, or you can just hit me up on my link tree there. Feel free to DM me through whatever social thing that you happen to like at any given point in time. I'm on most of them. All right, cool. So, building out a backend for a multiplayer game. You have lots of options. And I'll constrain things a little bit for this talk as well. Usually when I talk about multiplayer games, I like to talk about sort of real-time, sort of very interactive multiplayer games, right? Like we're talking the finals, we're talking, you know, what was I thinking of? Like Diablo, we're talking like Fortnite, we're talking like sort of like real-time games. There's a wide variety of multiplayer games out in the world. They're all wonderful. I like them all. But those are the ones I usually talk about. Grab some water. Now, we're here to talk about Google Cloud. Cool. And us at Google Cloud really are focusing on sort of being able to give you the power and flexibility and really the sort of a la carte nature to build the development and scalable platform for your multiplayer game in the way that makes sense for you, your game, your team, your organization, and the constraints and the benefits and the skills that you all have. So, like I said at the beginning of the talk, really what I want to focus on here is adding to your toolbox, being able to say, here's something else you can put in your toolbox to be able to be like, okay, this is a thing that I could use. This is a technique I can use. This is a tool we can take advantage of. We're going to talk a little bit about some open source stuff, and we're going to talk a little bit about some products as well. But why should you listen to me? That's a really good question. I just want to say, like, what we've built here and the demo that we will actually see at the end, and we're sort of going to step through as we go through, is not sort of done in isolation. These are sort of, I think it's, yes, last 12 months. We've sort of helped some of the biggest live service games launch in the last 12 months. I think they've gone reasonably well. And like, I think the names kind of speak for themselves. So it's both a combination of the expertise we have at Google Cloud in terms of our product and technological savviness, but also our experience working with some pretty decently sized customers. Before I forget as well, if you're here at GDC, make sure to go check out the Tech and Talk on Thursday, 11:30 a.m. I'm pretty sure I've got that right, if you want to see what their architecture also looks like as well. Okay, let's get stuck in the demo and let's talk about some stuff. So what we're going to do is we're literally going to step through some of my favorite bits, and we're going to see how they get built. So we're going to build a little team of backend devs. So first things first, we need a game client. And we're going to use a dedicated game server pattern, right? So we're going to use a full simulation of the game running up into the cloud. And so we need that. So for this bit, okay, Google Cloud, we can't help you that much. So we're going to use Unreal Engine, because that's a pretty good standard. Nothing too complicated there, and Unreal Engine 5 is pretty cool. We built this game called Droid Shooter. It's bad. It's really not a very good game, but deliberately so, right? Like, we just want to kind of give you a sample to be able to say, okay, cool, you can see that this is working. We don't want to distract you with anything that's too shiny. Also, we're not good game designers. Anyway, it's fine. But Unreal's awesome, so it gives us both a client and a dedicated game server, so we can do multiplayer interactions between all the players in our games. Sweet, thumbs up, easy, move on from there. Let's get into the good stuff. So, an next engineer is like, oh, cool, all right. We need some backend services for our game, and we need some sort of data storage for it that scales. So we're going to write some custom stuff for that. In this particular example, we were going to write, there's more to it in the demo, but we're going to write a profile service and some sort of front-end authentication service. So how do we do that on Google Cloud? And there's a few ways, but for this particular example, we actually ended up using just some custom Go code for writing both our front end and a profile service. A profile service is like, hey, who is this person? We're going to store their data. But what we chose here for our data storage layer is Cloud Spanner. People here are familiar with Cloud Spanner. Some of you, not all of you. That's good, because you're here to learn things. Fantastic. So Cloud Spanner is our relational database that is also able to scale horizontally. Now, I am not a database person. I will say that up front. But the way I like to refer to Cloud Spanner is very much as scale insurance. We've done a bunch of launches using Cloud Spanner, and it is usually the absolute most boring part of a game launch. It's remarkably difficult to take down. We use this sort of thing internally for a lot of our services as well, and it's been just a solid rock of data storage for across a bunch of our games. So that was an easy pick for us, so we can continue on from there. Okay, so we have some code. We've decided on our storage layer for our data. Let's do some continuous integration. I need to automate building containers, right? We're Google Cloud. We do containers. That is the thing we do. I need to automate building that for both my game services, but also for our game server. That would be cool as well. So we have this wonderful thing. It's called Cloud Build. Cloud Build is our continuous integration platform. It's flexible, and you can customize it to really kind of do whatever steps you need it to do. So each of the steps actually within Cloud Build are actually a container in and of themselves. Here in this example, we're actually building our profile and our front end. That Docker container image that is our step, that is just Docker running inside a container, if anyone's done Docker inside Docker stuff. It's building a file, which is our Docker file for that, which will build out our profiles, profile service. And then down in the artifact section, that's going to put it in what we call artifact registry, which is our Docker container registry. That'll actually store several other things. But what is cool about Cloud Build is you can write your own containers, which means you can write your own steps. So while I'm not actually showing it here, we actually have in this demo where we actually also build both our Unreal clients and our Unreal dedicated game servers using the Unreal Dev Containers project, if you're familiar with that, which is super cool and a nice way to automate both building your dedicated servers and your clients. So having the flexibility of containers in this space, super nice, and that gives us the containers that we need to run our services, which then talk to our databases. Sweet. All right, we have containers. Let's put them somewhere. I think you can probably guess where this is going. It's Google Cloud. It wouldn't be a talk by Google Cloud if we didn't talk about Kubernetes. That's how that works. So probably unsurprisingly, we put our containers inside Kubernetes Engine, Google Kubernetes Engine. I want to highlight one particular cool thing if you haven't looked at it before. Who here has used a GKE Autopilot? Oh, about like a quarter of the room. Sweet, that's nice. GKE Autopilot is, I actually think, really slick. So a lot of people have used what we call GKE Standard, which is like our managed Kubernetes offering. GKE Autopilot is basically Kubernetes with a few minor caveats here and there, but where you're paying for your pods. Like, so your CPU and memory set on your pods, but you're not actually paying for the nodes themselves, right? You're not at least aware of the payment of what you're paying for your nodes, right? Like, you're just looking at, okay, if I'm running a pod and it has this much CPU and memory, I know what I'm paying. If I'm not got a pod, I'm not paying anything. This means actually two very cool things. One, it means it can be really easy to be able to say, okay, how much is this player costing me? Because I have this many pods for this many players. I know what my costs are for my pod. If I'm not playing, cool, I pay for it. And two, just from an operational point of view, when we were building this demo, none of us at any point in time had to worry about what the cluster size was or where it was running. It was like, okay, if one person, we were a global team, each of us working kind of asynchronously, so if one person kind of adds another service where they need to do a thing and it has some resources it needs, I can pull that down and deploy it. Autopilot is going to scale automatically for me. I'm not worrying about my nodes. I'm just being like, kubectl apply, or we can do some more automated stuff. And I'm not having to worry about it. It could be otherwise, I'm building a service, I add a node so it fits. Somebody else builds a service, they add a node to fit. Oh, actually, it's not as big as it should be. It gets kind of annoying. I'm actually a huge fan of GK Autopilot. It just kind of works, and it's very cool. And we'll talk about it a little bit more as well. OK, so we've got some services. They're running on a GK Autopilot cluster. Dope. Let's do some matchmaking, all right? But we need a matchmaker that scales. So in an ideal world, what we want is a matchmaker that doesn't shard our player base, that is able to handle the global set of our players worldwide, and then look for appropriate matches for them within the constraints that we have within our game. And hopefully really customizable, too, because every game's matchmaker is different. Anyone here use OpenMatch? A few people in the front. Not as many as I'd like. That's OK. That's fine. That's why you're here. So OpenMatch is one of our open source projects that we do for gaming at Google Cloud. OpenMatch is, I like to refer to it as an open source framework for matchmaking. It primarily handles the problem of how do I have custom match logic, and how do I scale that to a global player base. We have a variety of pieces to it, but essentially you end up writing your own match function. You plug it into the match framework, and through a series of profiles and your custom match functions, you're able to define groups of players together and then put in your own custom logic for how those players get put together into groups, either latency, social graph. Really, it's entirely up to you. It's really extensible. It's been used in a bunch of game launches as well. And we're using that as well for our game. OK. So we've got matchmaking. We've got some game services. Sweet. We've used both Google Cloud and some open source. So let's keep going. Let's talk about game servers, because we did talk about that a little bit as well. And this is something that's very near and dear to my heart. This is what I do most of my days. So I need somewhere to host my game servers around the world. So we're doing the dedicated game server pattern like we were talking about. And because we're running dedicated game servers, if people haven't read those, used those before, we need to put those dedicated game servers somewhere close to the players where they are, because you have certain latency constraints in that. Right? Unfortunately, we can't control the speed of light. It's a real shame. So that means that we need these game servers to be placed in infrastructure that is placed all around the world. And we need some ways to manage those game servers, because their life cycle is a little bit different than, say, a web service or something like that. So let's stop it some more into the open source land. Anyone here run a Agones? This is fun. I get to poll audiences. All right, a bunch of you. Fantastic. I love you. So Agones is a project that I helped found, so I feel very sweet about it. But Agones teaches Kubernetes how to run game servers. The short version of this is essentially, if you have players playing a game on a game server, do not shut it down, do not touch it, people get mad, don't do that kind of thing. But it gives you all the capabilities of a Kubernetes cluster and all the wonderful things that come along with that, including the ecosystem and kubectl and all the other kind of CI/CD tooling and everything else that comes with it, so that you can run game servers on top of Kubernetes. That means then when you come to us and you're like, hey, we want to run on Kubernetes, we can say, cool, you can take Agones and we can put it on GKE standard, but also GKE Autopilot, like we do in this demo here, so that you can have a global set of clusters around the world for all your game server needs. I'll dig in a little bit here on one of that topics. So GK standard is awesome, right? You have all the bells and whistles for VMs and machine types and all kinds of great stuff there. GK Autopilot, which was, I want to say, we ended up supporting that, I think, in the last year or so, is, again, you get the same benefits we were talking about before, which I think are really cool, in that you can choose a machine class, but again, you're only paying for the pods that you're running. So again, rather than being like, how do I divide up my node and worry about how packed my node is, which Agones does some really great work for, if I'm running on GK Autopilot, I don't care about how packed my nodes are, because I don't care about my nodes. I care that I'm paying for a pod and how much CPU and memory it's running, which also, again, makes it really easy to say, I've got this many players on a pod, this is how much it costs me, and I know what to do from there, which I think is really, really cool. So what we're going to do in the demo as well then now is like add Agones clusters to each region. We'll end up with one in the US and one in EU and one in APAC, all around the world. And actually in this demo, half the clusters are standard and half of them are autopilot, and I have actually no idea which one's which. So that'll make things fun. All right. So we're putting a bunch of stuff together. We've got, let's see, 1, 2, 3 times 2 is 6, plus an autopilot cluster. So we got 7 clusters around the world. That's a lot of clusters. No, we could have more. I've definitely seen more. But there's a kind of tricky thing that it also happens here too, which is, okay, we've got services in one cluster, and we've got a bunch of Agones stuff in another cluster. You start to step into this world of like, how do I get clusters to talk to each other? There's these demarcating lines between clusters, and it gets messy, and you're like, what's going on? Like, how do I handle that? And I would actually say this is actually the project that taught me the benefit of service meshes. Anyone running like Istio or Linkerd or Traefik or anything like that? I see some hands in the back. Cool. That's fine. So service meshes are super neat, but also I feel like one of those projects and products out there that is like, when you hit the pain point of needing a service mesh, you're like, oh, I need a service mesh. But until you hit that pain point, sometimes you're like, why do I need this? I don't understand. So what we're using a service mesh for, and there's a bunch of really cool stuff that it does, is as the vehicle to allow us to set up cross-cluster communication in a way that is, well, once set up, relatively easy to implement. So Google Cloud, we have Anthos Service Mesh. It's part of our GKE offerings. You can set it up to be installed inside your clusters. There's a little bit more to it than this, though not a huge amount much. But what we can actually do is once we have it up and running, we can take our pod and we can add that istio.io rev label. And basically at that point, we now have cross-cluster communication. We're like, this is available to us. We have to actually also add the service and stuff too, but it kind of gets that simple. And then we can also do some more complicated stuff too. There's all sorts of really cool stuff you can do once you have this set up that I feel like a lot of people end up doing by hand. I've definitely done that myself, kind of written it myself, where I'm like, how am I sending traffic to different places in service discovery? And I really don't want to do that work by hand anymore. Where we can do stuff like have an endpoint that is global, basically across all the clusters that we have, but also be able to like do filtering on it, like send the requests to a certain area. So let me explain actually how we do that and why we do that, because that would make more sense. So one of the things that Agones has is we have this thing called allocation, which is basically like, give me a game server that matches this criteria and mark it as having players on it. And it's an endpoint. It's like a gRPC or a REST endpoint. Open match, when it's done a matchmaking thing and put some players together, it needs to be able to say, hey, I need a game server so I can put players on it. But as we were talking about before, we need to be able to pick a region where those players are based on their latency information. But if we only have one endpoint, thanks to Anthos Service Mesh for allocation, and we're sharing that across all the clusters, how do we do that? And there's this really cool thing where if you add a label to a pod in a particular cluster, you can put that label as well on the header for your HTTP request, and it will filter to the pods that match those. So we can actually get is Giovanni here? Anyway, it's fine. One of my teammates came up with this pattern, and it's awesome. I love it. So we can do it so that if we just put the region as a label on that particular region's cluster, we are able to target certain regions when we're like, OK, this person, they're in APAC. We can see their latency information. Go give me a game server with region Asia East 1. And the service mesh does the routing to the cluster we want. And that becomes just a really slick way of doing it. And then we can add clusters, remove clusters, do all that kind of good stuff. And the service mesh makes that all kind of seamless for us. OK. Whew. So we're adding more fun stuff. OK, we have, I think this is the last bit, which is, I love continuous integration. Continuous integration, not so useful unless we're talking about continuous deployment, right? First iteration of this, we put it in by hand. Awesome. But nobody writes bug-free software. At least I don't. I'm not that special. Maybe you do, which is great. But we need a way of being able to say, OK, we've got new versions of software. I need to deploy it out. We've got like 7 different clusters. How do we do that inside Google Cloud? We have another product. It's called Cloud Deploy, strangely enough. And it is a fully managed continuous delivery system for GKE, Cloud Run. I think actually we just released custom ones as well, I'm pretty sure. And we can use that integrated we use it with Cloud Build. You could actually integrate it with whatever you want to push out manifests that have the information we need to our GKE clusters. So in our particular instance, we're pushing out deployments, which are just your standard sort of like, here's my number of pods to run. But also for Agones, we have a concept called fleets, which is how many game servers you want in a particular place. And we actually do it for all of our services. But here, actually, I'm showing you we have each of our regions for where our game servers should go. And here I actually say, OK, so here what we're going to do is we're going to do a cloud deploy, and we're going to push to all the clusters in Asia East. I know some of us have seen the trick where it's like you send a test set over to Australia because it's a relatively small country size-wise, and then if it goes well there, then you move it around the world. So we're going to do a similar thing here. And once that's gone well, we can do our rollout and promote it up to Europe West, which we haven't done yet, and then we can also promote it up to US Central. More recently, Cloud Deploy's also got things like automations and stuff like that. So like you can even automate the promotion of stuff. If you see something going bad, you can roll it back. You can do approval gates. You can really set this up in a sort of whatever pipeline you see fit, either individually at cluster level, like 1, 2, 3, 4, 5, 6, or like here we actually have 2 or 3 different clusters behind each particular target there. OK. Whew. That was a lot of stuff. Let me show you what is actually a simplified version of what the diagram looks like. But the final diagram, it's fine. It's fine. It's fine. We have a lot of things. But I think, you know what, you start to put this stuff together, and you're like, OK, yeah, it gets complicated, right? We've all built backends for production. If you want the more full version of this, it's all available on GitHub. But here we have some players, right? So what do we end up with? They end up talking to Cloud Load Balancer that talks to our front end, that does all our player authentication. Make sure they're talking to the back-end services that they should be or shouldn't be. So that will talk to their profile service. So who am I? Should I be playing this game? Once I get into a game, I can talk to OpenMatch, which will talk to our custom match functions, and be like, OK, cool. In this case, we're going to have 3 players that need to play together. That all goes down through Anthos Service Mesh once we have some players together to go talk to our Agones clusters, which we have in multiple regions around the world. And then also, we have some CI/CD with Cloud Build and Cloud Deploy. Cool? Reasonable. All right. But here's what you're really here for. You want to see me do a live demo, right? Like, I'm pretty sure that's the fun bit. So we put this all together. Actually, I'll show you a couple of cool things because we have a little bit of time. Let's make sure I get this right. Hey, almost. All right. So just to show you what this all looks like in the Cloud Console, and I'll do this over my shoulder because it's fun. So here you can actually see we have, yeah, shrink. Thank you. You can see we have multiple clusters here. So here actually that's one of our standard clusters. That's one of our autopilot clusters for game servers. There's our same thing in US West. There's our game services autopilot cluster. So we have a few clusters. It's not too bad. One of the things I do like as well is there's some really nice stuff in our console, which I just like to show off a little bit, which is being able to actually search across clusters when you start to have lots of clusters so you can see what's going on. So here I actually have a saved view of just the services that are available inside that autopilot cluster. You can see we have a few more than we're talking about today, but there's a bunch of OpenMatch components as well as our front end and our profile. So that's all super nice. So we can see that's all up and running as it should be. But there's also this super nice thing here called the object browser. So if you're running any custom resource definitions, which we use in Agones, for example, I can actually start to see, and let me just refresh this as well, make sure it's up to date. Yay, internet's working. We can see that we have fleets, which are groups of game servers, again, across all 6 of our clusters. But we actually can go down to the game server level as well and start to dig down and start to see, OK. Not running a huge amount because it's just me playing. But we have a few on each cluster around the world, and it also makes it a little bit easier to look at. Cool. All right, let's play the game because it's fun. So one of the actual also fun parts about this demo is we actually set up a VM for you that has a graphics card in it, because not everyone can run 3 instances of an Unreal client on their machine. And of course, we're using Chrome Remote Desktop. Oh, and I didn't shut it down before. Oh, that's sad. All right, that's fine. Bear with me. Pretend like you never saw anything. I know. There we go. I'll hide it. Fantastic. All right. So we have actually a custom game launcher. Let me fire that up. You'll notice it says my name. That's my name there. It goes to the profile service. I'm logged in. Awesome. Fantastic. In our launcher here, we have it set up so that you can actually run multiple instances, which we saw before. And we'll run it a little bit small because we have only a little bit of space on the screen. And we'll shut that one down too. I will say, actually, Chrome Remote Desktop is not bad for this. It does a decent job. All right, let's open Droid Shooter. It'll give us 3 windows. Oh, strangely enough, like it looks before. Okay. Again, I'm doing this over my shoulder, which is hilarious. All right, so this is also, like, our client is connected to the profile server, so you see my name there. Fantastic, and you see it across the board. So let's play an online match. That's going to go through our front end, talk to OpenMatch, find us the other 3 friends we have sitting here, go back to Agones and say, hey, can I have a game server in the area that makes sense, which is probably somewhere in the US, and we're connected, and we're playing a game. Cool. Like I said, it's not a very good game, but you can see me flying around, and if I try and shoot at one of these fellows, come on, I can go blam, 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 blam. Cool. If I shoot them long enough, they disappear. Go on, disappear. Thank you. There we go. Fantastic. Woo! Game. Fantastic. I win because I'm very good at this game that is not very good. Much credit to one of my teammates, Nikolai, who built this because I don't know how to do Unreal either. I know how to do backend stuff. Fantastic. Okay, cool. So to wrap things up, and let me get the screen up that I want, which is that one. Beautiful. All right, so if you're like, this is cool, I would like to learn more about the stuff that you do and the things that you have. You can actually see this entire demo. You can deploy it if you want. It will be expensive. So I put that on you. That is fine. But you can see it at github.com/Google for Games, global multiplayer demo, along with all the other open source stuff that we actually talked about today, both OpenMatch and Agones, as well as several other open source projects that we work on Google Cloud. If you want to know what the game stuff that we do at Google Cloud in general, cloud.google.com/games is definitely the place to go to. And finally, like I said before, if you have any questions or you want to just get in contact or you're just like, hey, Mark, you seem really cool. Maybe we could be friends. That's fine, too. You can contact me. My link tree is there. All my social media stuff is there as well. Awesome. Finally, thank you so much for spending time with me. I know it's the end of the day, so hopefully you learned something new and learned something you could put in your toolbox for your next multiplayer game. Thank you very much.